Well, hello friends. Today we're going to continue working on menu applets, and we're going to do the little audio applet here next. And if you're not familiar, we did a video where we converted the CPU graph here. It used to live in the Windows server. Now it's a separate process called CPU graph.menuapplet. And the way it works is that this program, it creates a little applet thing that's hosted by the Windows server, and then it provides a bitmap that is what the Windows server puts in the menu. So if we actually look at CPU graph.main or CPU graph main, we can see that it's created by making an IPC call here to the Windows server called create menu applet, and then we have the API set menu applet backing store, and finally invalidate to cause a repaint. Now, this API here is extremely bare bones, and it's not going to be fun to work with this. It's just going to be really cumbersome if you want to do something up here. Like if you just want to do like I don't know, put like a label or something or a button, it immediately becomes very cumbersome because you have to paint everything yourself, and there's also no event management. So I think I was going a little bit in the wrong direction in the first video about this, where we made this new API for applets. So I think what we're going to do is we're going to pivot here and switch this over to being a window, and that will give us event management for free. And more importantly, though, it will enable the user space side to write this as any other libgui application. Just that the window will be created with some special flag, and that flag just means this window will live in the menu bar. But then that will allow you to use all of the widget stuff, widget layout, things like that. So I think that is definitely a better direction, and we're just gonna go in that direction instead. So we'll have maybe like a different API call, or actually we already have create window with type. So maybe we can just make this be a type. Let's see how we would do this. So in gwindow, what if we, let's see, type, set window type, right? So where are the window types? Right here. Menu bar, so we'll just add one here. We'll call it like menu applet. And WS window type, so we should add it here as well, menu applet. Okay, now we have added a window type. Now, what are we going to do with this window type? I guess when it shows up in the Windows server, in the window manager, menu manager, let's see. Oh, I feel a sneeze coming on. Excuse me. Okay, so currently we have this vector here with all the applets in it, and obviously it's going to have to be a little bit different. Now, maybe it will make sense to keep the applet as sort of a metadata thing, but nah, probably not. We can just get rid of this in favor of a window. So maybe we'll just change this to WS window, and we can keep calling it applets. That's fine. So maybe we'll just switch these to being this way. Validate applet, draw applet. Okay. So the applets are now just WS windows, just like any other window. And client connection. Where do we get the create menu applet thing? So instead of making a WS menu applet, we can just get rid of this whole API, because we're just going to use regular windows for all of this, actually. So bye. That was simple. Menu applet goes away. Way. And away you go. And it'll just become yet another window, I guess. Okay. Now, when we create window, this one is going to have to act a little bit differently depending on how things, if it has the type. So I think we're going to look at the type here and say if window type, or I guess we can look at the message directly, if message type, or wait, hold on, this thing has the right type. Menu applet. If so, then window manager, the menu manager, add applet window. And the window has been moved from at that point, actually. Okay. Now, I guess when we destroy a window, we want to remove it from the menu manager as well. So we'll do that, I guess here. If window type is window type menu applet, then window manager, menu manager, remove applet window. All right. So obviously this is not going to be enough to solve everything, but we'll start with this, and then let's go and look at the CPU graph main. So this code, we can basically get rid of a lot of it, and we want to instead switch to just using a regular G window. So I think we'll turn this into a widget, actually. So this would be something like a class CPU graph widget, or maybe just graph widget. It's a public G widget. And we don't have GWidget here, so that's what we're going to do differently. We're going to get GWidget this time. And then all of this gunk, this becomes a private member here. Maybe this stuff here becomes also some kind of a private thingy. And this goes away. This will be our timer callback, I guess, or repaint. Maybe this is actually our, we have a timer callback and then we have a separate paint function. So this will be the timer callback. And we'll just do an update. So we can do this like, give it a timer event. So timer event, C event. Oh, is that a C timer event? Perhaps, yeah. And this guy can just do this stuff right here. So he will do the fetching of the CPU usage stuff. I guess we need these guys to store the state from the last fetch. And CPU history becomes M CPU history. By the way, in case you don't know, M underscore is just a convention prefix for member. So this is something I use for private members. And this code right here goes in the paint event. So, all right. Okay, and I'm gonna paint into this painter, add clip rect, event rect. And we're gonna fill the event rect with black, and then just dump out the CPU history in a little graph. So, wait, what's this? Applet rect.x. What does that even mean? Applet rect is always at x0. It's a bit strange. Guess we can do something like this. This will also always be 0. And we don't need to say rect for these, actually. We can just say height. Okay. Now, what remains here? So auto window is G window. Construct. Okay, just converting this application here, no big deal, to be a regular libGUI application. So now that we've made our widget upstairs, we'll just say widget is graph widget construct. Forgot to add a constructor for this guy. I think we'll just call the base class with null footer because we don't have a parent widget. Set main widget and window set type window type G window type menu applet. Okay, now that's the thing that's going to make everything different. And then we do windows set rect. X and Y don't matter, but the size does. In fact, maybe we could call this API just to make that a little bit clearer. Okay, so that's pretty cool, right? Okay, probably we can get rid of something up here, I thought. Maybe that one, maybe this one. Okay, so now in order to get timer events, we have to actually start a timer. This is something that I took from the cute way of doing things. It's that anybody who inherits from C object can actually just start a timer, and then the event loop will call this timer, or rather will deliver a timer event to this C object every so many milliseconds. So we'll just start a timer at 1000 milliseconds, which means that the timer event will be invoked by the event loop on this object every second, which is really, really handy. And it just allows you to have a simple timer mechanism with no separate object or anything needed. Okay, so I think this app looks pretty good. Obviously, it's not going to work, but just out of curiosity, what would happen if we still run it? Because after this point, like if we do everything right here, I think all that we really need to do is do everything correctly in the Windows server side of things. So we need to fix some things up. What is this? What are you complaining about? New client connection. Is it pure virtual or something? Did we forget something in there? Yes, we did. It's an abstract class because we forgot to remove these APIs in the IPC definition. Goodbye. All right. And let's see. Phone keeps buzzing over there. That's what I'm looking at. So menu applet. Right, we're gonna get rid of all this stuff. So let's just remove it. Window servers, Window server, menu applet. Goodbye, menu applet. We hardly knew you, and now you're gone. Poof. Menu applet. Okay, and right, so now we got to change all of these guys to be WS Windows instead. And Right, the applets were storing their rect in the menu bar. So I think we're going to have that information on the window as well. It'll just be like a nice little extra storage for that. What do we call this now? Back? No. What the hell is the name of it? Isn't it backing store? Yeah, backing store. Okay. So backing store. I can't call that because it's not const. Well, if we had a const version, that would be okay. So rect in menu bar. I'm thinking we could have a subclass of WS window that would be like a WS menu applet window or something like that, but it doesn't feel necessary at the moment, and really the only thing I want to do with it is just stash this one thing, this one rectangle, because we want to know where in the menu bar this particular menu applet is located, so that because you can have many applets and you need to know which one is on the left, which one is on the right, stuff like that. So we'll just put this on WS window for now. Only used by menu applet WS window type menu applet. Perhaps it could be a WS window subclass. I don't know. Rect. Okay, so now how are we going to do this stuff? So currently what we do is we have draw applet, but nobody, oh no, somebody calls it. Okay, so it's called by, the code that draws the menu bar, right? So whenever the menu bar is updated, we also iterate through all of the applets and draw them, which means that we take the backing store of the applet window and we draw that into the menu bar. So maybe this would kind of sort of work. We definitely don't want this to show up as any other window. We don't want it to have a frame. We don't want the window switcher to find these. So I think normally in order to make that happen, to make it show up as a regular window, we would have to add it to the menu manager's, here's the canonical authority on window order, and also this also happens to be the canonical order of windows that are respected by the window manager. So it's for each visible window from front to back. So then it iterates like first the window switcher is the frontmost, and then the menu is the next, menu bar, and so on. And I think if we don't put it here, if we don't add menu applets to this, then the window manager will just kind of not care about these windows. We'll just leave them alone because window management uses this iteration helper to do everything, more or less. There are a few cases where we use for each window, which just walks the entire list of window objects. But I'm not sure. I'm not sure if we need to care about that. I guess for this type of thing, for each window, wherever we're doing for each window, we should probably consider if it's a menu applet window or not. So this is when you're running animations. This is for windows, for each window. We'll see. Okay, so is the CPU graph even running? Yes, it is. Okay, but it definitely didn't show up. So, not a huge success, but I wasn't expecting that to just work. So, but at least it runs, right? So it started up and presumably created a window. Did we do Windows show actually? CPU graph name. No, we forgot to do Windows show. Then there will never be a call to create window. Menu applets, CPU graph, and sync and run. All right. So maybe now we'll get a crash instead. We'll see. Oh, look at that. That's pretty freaking cool, actually. So now this is a G window. Regular old G window, just running up here. And it's not hogging that much CPU. Sitting at a steady 0.2, which is a little bit surprising, but at the same time, it is drawing stuff. I wonder what it's doing. I guess we can, just out of curiosity, I just want to find out what it's doing. Hey, wait, why doesn't my window key work? I'm just going to profile it. That's my new habit anyway. So, oh wow, that's not very busy. Just doing JSON parsing. All right, well, that's to be expected because JSON parsing and freeing memory. JSON parsing is to be expected because this thing up here gets all of its data from proc all, which is this big JSON blob that has all of the information about all of the processes and threads in the system. And probably you already know this if you're a regular around here, but proc all. It's very cool. One of my favorite things about Serenity, actually. I mean, the whole JSON data in the proc file system, it's super duper handy to work with. So when we do update on one of these, I kind of feel like that's not really working. That's just kind of working by accident at the moment, because what happens if we stop updating because of the timer? Because we have this clock up there now, right? So if we stop updating because of that, where do we do that? Here, right? So we say only update the time label twice per minute instead. See how that works out. I feel like we're not going to update the CPU graph either. Right. Yeah. So this will only get repainted if I do something with the menu. Right? If I'm interacting with it. If I stop doing it, CPU graph invalidation does not happen. So we got to fix that. So in client connection, where we get what happens, actually, let me show you. In the CPU graph program, what we do now to update, to repaint the graph, and every time we get this timer event, we fetch the latest CPU usage, and then we call update. And updating a G widget, which this is, works. You know, it's very similar to how Qt does it. Basically, if you call update with no rect, then it updates the whole widget. Otherwise, you can also update only a partial rect, which we should do more of. But anyway, the widget will pass this information on to the window that it's in, if it is in a window. And then it gets up here in GWindow update, and it gathers all of the pending paint event rectangles. And we don't send a message to the Windows server right away when you do update. Instead, we just collect as many of these rectangles as we can, and then the next time we get back to the event loop, then we send out here. So this is what happens. We set up this deferred invocation, which just means that next time we're in the event loop, call me back and execute this lambda, basically. So next time we hit the event loop, we gather up all the rects, and let's see, I'm making a copy of the rects here. This could probably be avoided. I'm not sure why that is, probably some stupid reason. But anyway, we post an invalidate rect message to the Windows server, and it should be called invalidate rects, probably because it has a list or vector of rects. So let's go look at how this is handled in the Windows server. And I love, by the way, that there are like 5 fewer layers of IPC less these days, since Windows Server has been ported to the new libIPC stuff. So we end up in here, and we just iterate the list of rectangles that the widgets have decided to update, and then we call window request update for each rectangle. And that ends up here, where we basically gather up all of the pending paint event rects and then post a message back to the client program saying, all right, fine, paint, I'm ready. And the reason that we do this is, maybe there's a better way to do this, but this kind of throttles the painting so that otherwise, if you're a program and you decide yourself when it's a good time to paint, you can just spam paint all the time, right? And you just send whatever you paint over to the Windows server, but maybe he's not able to display all of it. So what we do here is we just queue up all the paints, and then the client tells the Windows server, hey, I want to paint. I have some rectangle that needs to be updated, and then the Windows server, when he finally responds like, all right, fine, paint, then that's what achieves the throttling of painting. And now that I say it out loud, I feel like there's probably definitely some better way to do this, and like maybe cut out some of the slack time, because I feel like we're probably losing some time there with the back and forth, but it works well enough at the moment. But maybe for doing something like video playback, we might have to look at this. We're probably definitely going to have to look at this type of stuff and streamline things. Anyway, so we post a paint message back to the client, which happens here. So we make another copy of rectangles and send them right back. These rectangles have been pruned a little bit by the Windows server, because the Windows server, he knows like if something is obscured by another window and stuff like that. So he's able to make some optimizations possibly to the rectangles. But we send this paint message back, which ends up in the Windows Server connection and becomes a multi-paint event that's posted to the window. And the important thing now is that, because we don't need to follow that trail forever, but the important thing is that we sent this update request to the Windows server, right? And it has a bunch of rectangles, and those rectangles are in the menu applet window. So when we call, what was it? Or actually, we do have to follow the trail to understand what happens next. So in request update, we sent the paint message to the window client, which ends up as a multi-paint event, which is handled by gwindow here. And basically, you get a gevent multi-paint in the window event handler, and that will allocate a backing store if necessary, paint into the backing store if necessary, probably is. And then finally, it will send a message back to the Windows server, again, making a copy of rects. Why are we making so many rect vector copies? We need to do less of those, probably. Anyway, we sent a did finish painting back. And this is the thing that ultimately is going to trigger the Windows server to actually paint something. So here, the did finish painting means that the client has now painted into the backing store, and he just needs us in the Windows server to put the bitmap on the screen. And that happens here. So we invalidate. We tell the window manager, hey, invalidate each rect in the message rect list. And here where we invalidate, this is going to have to be different for menu applets, because we don't want to invalidate the window because the window is not composited by the Windows Server compositor anyway. We need to invalidate the menu applet. So if window is, or no, window type menu applet, then menu manager invalidate applet. Oh, that's pretty good. Window. Will that work? Oh shit! It needs to have a const WS window. What? Why do you need a non-const one? Because you call draw applet. That takes a const one. Seems like that could take a const as well. Invalidate applet. So now this is going to be a little bit inefficient because we're going to invalidate the whole menu bar whenever you invalidate an applet, but that's the same situation we had before, so I think that might be okay. Okay, invalidate applet, window, and rect. That's pretty cool if this works out. Not quite. He's running, but we are not invalidating unless we interact. All right. So, still not good enough. Fine. Do we not end up here, I wonder? Because if we end up here, then we should be good, but maybe we're not in this invalidate because it has a few overloads, so maybe I was mistaken. Menu applet. Just make sure we get rid of those. So, oh, let me actually, I think maybe they got installed here. Menu applet. Yeah. So where were we? Backup. Client connection. We wanted to look at that did finish painting message. Did finish right here. So for each rect, we tell the window manager invalidate window rect. So that was the right overload. Validate menu applet window, say rect. Oh wait, did I not? Maybe I didn't actually sync before I ran there. Oh shit, yeah, I didn't. Okay, so maybe this works. I just forgot to copy the compiled program into the disk image. Yeah, it works. Check it out. How cool is that? Okay, so now he drives his own updates. Very nice. And actually, while it invalidates the whole menu bar, you can see that it only draws this part. It doesn't redraw the time, so that's good. Because if I go over here and mess around, then it updates the clock all the time. But when this thing drives its own repaint, then the clock doesn't get updated. So, perfect. Menu manager, right? So this is really good. Let's turn this guy back and invalidate menu applet. I just want to get rid of that. Okay, so let's see what we have done here. We just got rid of all of the menu applet IPC stuff, and then what happens if you kill the CPU graph PID 7? 7, kill 7. It restarts, I think. Haha, PID 18. Restarted by Sergey's magical system server. Frickin' awesome. All right. And you wouldn't even know that it crashed, right? Check it out. Here's the CPU graph menu. Poof. Oh yeah, you get a little flash and the history, CPU usage history goes away. But that's so cool that it starts over. Damn. That's really, really cool. Okay. So I think this is great. This means that now we can just create a window on the client side, and that's all it takes to make a menu applet. Don't need any special IPC. So we'll say Windows Server plus menu applets or CPU graph. Oh no, let's just say plus CPU graph. Make menu applets be regular windows. Instead of implementing menu applets as their own thing, they are now WS windows instead, just like all the other windows. Windows with WS window type or of window type menu applet. I said instead twice. This makes it much easier to work with them on the client side, since you can just create a G window with the right type, and you're in the menu bar doing applet stuff. Cool. Of course, we didn't look at the event stuff yet, so it's definitely not going to work, but that comes next. Now we're going to actually convert the audio thing. So menu applets, we are going to make a new one. What do we call the other guy? Maybe audio applet, audio sound control, audio. It's gonna have some name like .menu applet. Maybe that should have been .applet. I don't know, but it will be called like sound audio .menu applet. Yeah, let's call it that, audio. Okay, and I think we'll borrow some stuff from here. And we'll just say audio.menu applet. And we will also put it in the system server config, just like we have the CPU graph menu applet. And what else? That's pretty good. So meta, and then I guess we gotta make sure we build it. Audio to build it first. It's fine. Build root file system CPU graph. Okay, so now we should be cool. So audio main. This is going to be something else. So we're going to take the code from the menu manager that does the audio thing, and this is going to be, I know that Sergey is going to be happy about this, because he was not happy that I was making a connection to from the Windows server to the audio server. And I agree that that's pretty crappy, because it doesn't make sense for Windows server to connect to audio server always. everyone should just do their own thing, right? So that's part of why separating out these applets from Windows Server is also really, really good, because it allows Windows Server to focus on Windows serving. But you can see if we look at Windows Server, come here, then we can see that he has a local socket connection to the audio portal, which is not super great. So let's get rid of that. And I guess first things first, we'll just, oh shit, no, we don't want to convert all of that. Audio widget, let's call it. Just in this file, it's enough. Don't need a circular queue, don't need statistics. We are going to need some audio client stuff. And I guess we're going to have to compile that in, actually. Make file common. Oh, it already links against libaudio. Fine. So then this gunk here, we'll take all of this stuff from the menu manager and just put it down here instead. And audio. The audio rect stuff, we're gonna have to tweak that a bit, the way it's used. The audio bitmap, we'll take care of that. This will be, we don't need a timer event for the audio stuff. This is purely on demand, or if we get a notification from the audio client, actually. Anyway, in the paint event, we don't want to paint all of that stuff, but we do want to paint a little bitmap. We don't need CPU usage, but we do need our nice little audio client code. So where are you? Audio, a client connection. Keep thinking that we should rename a client connection to something a little bit more understandable, like audio client connection, maybe. I don't know. I go back and forth with naming scheme, and something I'm not super happy about, because I got like in libgui it's G everything, in libcore it's C everything, but then in libhtml there's no leading letter, and in libthread it's like everything's in the libthread namespace. I need to make my mind up, I think. Anyway, not right now. So audio client and audio muted, I guess we want to keep that. So we have the audio rect. Audio muted, that's the thing that we want to know. So we're going to subscribe to information about that, and then we need the muted bitmap and the unmuted bitmap. So here we go. And of course, we don't need to split at any specific location. We just split at 0, 0. That's fine. And we don't need to fill the background with black. We can fill it with warm gray. What do you think about that? Cool. Or actually, we could even clear the background and use an alpha channel. But let's do warm gray at the moment. Let's fill it with red, just so we see that everything's working. Okay, so here, instead of doing this Windows Server stuff where we redraw and invalidate window, blah, 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 now we don't have to think like that. We can just do update. Okay. And this will give us a chance to debug why we're not getting that notification, I guess. So debug muted, state changed, muted. And this one can be 16 by 16. Will this just work? Wouldn't that be super dandy? I feel like I'm messing something up, like especially in the Windows Server, because we're getting rid of the audio rect and at least some code just depending on the audio rect. So we'll get rid of the audio rect and instead Because what's his problem? That like something is relative to the audio rect. Now it's going to become relative to the date rect instead. So it's a time rect. So the right edge x becomes the time rect left minus 4, say. Audio rect be gone. Oh. I guess this is where the mouse events come in, actually. Also, I wonder, would the audio thing even react to... Hey, well, okay, so it reacts to muting and unmuting. So the reaction happens, it's just that the events don't get delivered. So we're gonna have to do that differently anyway. So we'll take that code and go in audio, the audio applet. When you click on this guy, we are gonna have ourselves a little mouse down event. And we already know that it's mouse down. We should check the button. G mouse button left. If it's not that, return. We know that we're in the audio rec because we are the audio widget. So here gives update. Okay, I think we're good. Now, of course, we're not going to get the mouse events, but we can at least see that everything would build now. Ah, still audio rect somewhere. Dang it. All right, right edge x is going to be the time rect left minus 4. I think that's what I said elsewhere. Yeah, same here. All right. Should probably cache that information somewhere instead of duplicating the arithmetic. But at the same time, I would like to get rid of the date thing as well and turn that into a menu applet. It'd be nice to run everything as a menu applet. And let Windows Server just do the compositing. In fact, then we could also consider doing a like a traditional, have a compositor process and then a window manager process. All right, so here we are. We got our red background. They've switched places now, but we can live with that. So let me just take a look at this image. Res, icons, 16. What's the icon that I'm using? KG. Res icons audio. Unmuted. Okay, so if we're 16 by 16, that's a bit big because this one is only 12 pixels wide. So I think we can make the applet 12 pixels wide as well. We'll just do that. And red, what if we instead just clear the rect, fill it with empty background color, so like from RGBA, something like that, 0 alpha. Oops. CPU graph. No, don't we have graph? Because I think, I don't know if this will work. Maybe we have to set the window up to have an alpha channel. Yeah, oh, now they're gonna, like, whoever launches the first is gonna end up on the right, I guess. That's probably something that we could do somehow, but for now, I think we're gonna live with that goofiness. So that became black though. Maybe we have to set the window up with alpha. Set has alpha channel true. Please respect my alpha channel. Okay, look at that. and we don't have to. Otherwise, like having the applet decide what the background color of the applet is makes it a little bit more annoying when we want to do like color themes eventually. So now it has a transparent background, which is neato. Okay, so now we want to get those events going. So in Menu Manager, we do handle events, and they are, let's see, if it's any kind of mouse event, then for each active menu bar menu. Oh, this iteration function is so ugly. Wait, for each, and then we have return false and return true, but for each, it's not branching on the return value. If. Wait, hold on. For each menu. Oh, here. Okay. I guess we'll say if it's iteration decision break, turn, and then here if callback gets iteration decision break. This will be a little more understandable. I don't like these Boolean. This is the way I used to do things. Now we use iteration decisions instead, so that it's clear what kind of decision we're making in this type of helper. So what this code is doing here is that for any type of mouse event, if we are hitting one of the menus in the menu bar, then the event goes to him. Otherwise, we'll fall through. But we can actually stay here because all of these event types, we want to send those to the window client. So let's see. Where do we normally do this? WS window? Maybe we can just pass it on to the applet. If we hit an applet, so how do we iterate applets? Just iterate over there. Oh, the applets are just windows, right? So applet m applets. If applet is null, then skip over it because they're weak pointers, so they can be null. If applet rect in menu bar contains event or mouse event position. If it doesn't, continue. But if it does, then applet event. I'm gonna give you this event, dude. You're gonna get it for free. Okay, will he make sense of it? I wonder. What will happen in WS window event? Event. He'll notice that it's a mouse event and called handle mouse event. Okay. And then he will just post a message to the client right away. So this is set up so nicely already. We'll just pass the information along to the client. Damn, dude. Thank you, Past Andreas, for making this sort of reasonably designed. Oh, and what did we mess up? Callback. For each menu, we're probably using that somewhere else. Window manager. No, not woman. Window manager. 264 was it? For each active menu bar menu. True here as well. Iteration decision continue. Dang it. I think that's all of them. So, the audio menu applet, so cool. It's really fun to see how everything's just coming together. Because I know I talk a lot about building like these temporary structures and scaffolding and things, and it's just lovely when you can go through your system like some time into it now and fix up these things. So we're not getting the events as expected. That's okay. We're gonna figure out why. Menu manager, you menu manager. Let's see. Are we here? Menu manager mouse event. We'll go here. Okay. And we'll say the mouse event position. Okay. Maybe it just has a stupid offset or something. It'd be nice if it would be that simple. So menu manager mouse event. Yeah, those events are not they're not relative. So if I click on this guy here, he's getting a mouse event probably very far outside of the widget, so it's not going to end up in the widget. We have to make these events relative. So do we have a translation helper? Yes, we do. So we're just going to translate it by negative applet rect in menu bar location. No? I have to create a temporary, okay. Local event. I guess it takes an amp, not a const amp. Okay, so let's see, menu manager mouse. Oh, well, sending local event position to applet. Okay, we're sending these events to the applets, supposedly. At least those coordinates look good. And let's see if we're getting anything in the applet. Mouse down event. Let's do the audio applet as well. Okay. Oh, we are getting mouse down event in the applet. Okay. So presumably we're setting muted. So we're doing a set muted call. Let's log this. Set muted. Audio muted. Sending local. We can stop logging that. Okay, so maybe now the bug is remaining in the maybe in lib audio or something. We'll see. Set muted true, and it's not reacting. Okay, it's good. It means that Windows Server stuff is hooked up. Set muted. Sends this message to the audio server. Let's see what he does with it. Set muted, message muted. So I wonder if it arrives. Oh, we're gonna need a bigger recompile here, actually. Maybe the message doesn't get to the audio server. Set muted true. Set muted true. Okay. Then why doesn't it become muted then? If muted is muted, then return. Okay. I guess mixer. Set muted. Was and muted. So set muted true. It was false, so it becomes true. Okay, and then it's true from then on. But it seems like we don't get the notification that this happened. But we walk all of the clients and call did change muted state. Okay? Which sends the muted state changed. But it seems like that message gets lost. I wonder if it gets lost because we are waiting for a response to set muted at the time, and then this thing sort of gets injected into the message stream and disappears because we're waiting for a specific synchronous response. So what if we did deferred invoke here? Wait, is this a C object? Yes, it is. Okay, so we can just do muted. So if we just do this on next event loop instead, would it just work? Let's see. No. Muted, not muted, muted. Okay, wait, so it does react up here. The clicking doesn't work. Okay, so that's kind of weird, but this isn't really what we came to hack on. So we know that everything is set up correctly as far as the applet goes, and the applet calls the audio server, and then the notification doesn't come back for some reason. So I think I'm going to leave that bug alone for now and just finish up what we've been doing here. So set muted can get rid of some changes that we have, blah blah blah, blah 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 blah. Okay. It's pretty good. Okay, git status, git commit -a. Windows Server plus menu applets. Move the audio to its own program. This patch introduces the second menu applet audio. To make this work, menu applet windows now also receive mouse events. There's still some problem with mute unmute. via clicking, not actually working, but call. Let call goes from the applet program over to the to the audio server where something goes wrong with the state change message. Need to look at that separately. Anyways, that's pretty cool to be able to have. It's pretty cool to have more applet running in their own separate processes. All right. Oh, and maybe we should stop linking Windows Server with libaudio. Just get rid of that. Things should still work. Anyways, need to debug this, but I'm not going to do that now because I think we're going to end the video here, but I'm just going to fire it up one last time. Say Windows Server, stop linking with libaudio. No longer necessary since the audio applet has been moved to its own process. Cool. So here we are. Did I leave some annoying debug messages in? Maybe I did. Set muted true. Yeah, well, we can live with that one. This is really neat. The audio menu applet sitting there doing nothing. Beautiful. Okay, so this is going to be it for today's video. So if you made it this far, then I thank you for watching, for hanging out, while we continue to improve the desktop in the Serenity operating system. I hope you saw something interesting here today, and I will see you next time. Bye.